With bill of material questions, it's always better to draw a diagram. The first question in these old questions is an excellent example of that. Considering the following product structure. Okay, so it's a verbal description. Each A consists of 2 B's and 1 C. Each B consists of 3 D's and 2 E's. Each C consists of 4 D's and 2 E's. How many D's are necessary to produce 400 A's? All right, so this is really a question in logic. You can try to figure that out by working with this sentence. I would draw a picture myself because we know what a product structure looks like. Each A consists of, how would we draw this? 2 B's, and I'm not going to write the 1, but 1 C, right? Each B consists of 3 D's and 2 E's. So in a proper bill of materials, the branches would show what you need to make each of the parents, so it would look like that, and other information. Each C consists of 4 D's and 2 E's. Okay, 4 D's and 2 E's. Now the question is, how many D's? Oh, that's what we should do next. Let's spot the target. How many D's to produce 400 A's? The key to this question, or I should say the easiest way to answer this question, is to first figure out the answer to a different but related question. That is, how many D's do you need to make 1 A? All right. Well, I have 3 D's over here, and I have 4 D's over here, so to speak, in this product structure diagram. Think of it as multiplying up the branches. You need 3 D's to make a B, and you need 2 B's to make an A. So 3 times 2 is, you need a total of 6 D's from this branch. Here you need 4 D's to make a C, and then that's all you need to make an A. So 4 times 1 is 4. So total, just logic, 6 plus 4 equals 10 D's to make 1 A. And by multiplying up the branches, what I mean is you're multiplying together that requirement of how many children do you need to make each parent. You say, all right, well, we have this answer that you need 10 D's to make an A, right? And then you go back to the original question, you sort of finish it off. Well, then how many for 400 A's? Well, 10 times 400 is, right, that's where the answer comes from. Okay, so that's a typical kind of standalone bill of materials question, much easier to actually draw the product structure. This next set of questions, the questions themselves didn't even fit on the page because all of this is the problem. This next set of questions is what I call a full-blown bill of materials problem, or excuse me, not bill of materials, MRP problem. Look at this. The XYZ company has hired you as a production manager of their North American fabrication facility. Your first job is to use MRP methodology, there's a big giveaway there, to schedule production for the next 9 weeks. The XYZ company has given you the following information. Why does this problem take up so much room? Because to set up an MRP system, or in micro level, to work an MRP problem, you must have 3 sets of information. Or to work an MRP problem on an exam, you have to have 3 sets of information provided for you. There's the bill of materials that they're using. Here are their current inventory records. And then here is the master production schedule. Right, those were our 3 inputs of MRP. And you say, all right, well, then now we're going to have to like fill out some records and stuff like that. Yeah, we probably are, and we could check to see if there's any just kind of interpretational questions that we might get away with first. Using your MRP schedule for the next 9 weeks, how much of Part C will be in inventory? No. Here we're going to have to do the whole thing and then answer questions because it's asking for us to create the MRP schedule. Oh, all right, so we have to set up this information system basically. And you will notice that there are blank record frames provided in the note pack. Right, and if you ever had to do anything like this on an exam, there would be blank frames provided so you don't have to draw them. But you still have plenty of work to do because step 1 is setup, meaning I have to take all of this information and I have to find a home for it on this page. Okay, well, the bill of materials, these are essentially the records in the system. So I'd better label them A, B, C, and D. All right, that's entered, so to speak. I'm not done till I've entered everything I was told. Okay, now the current inventory records, here's a bunch of information. They all have homes on the records. Lead time, let's see, for A, 1 week, for B, 3 weeks, for C, 2 weeks, and for D, 1 week. Okay, what else do I know? That's done. Lot size, lot for A, right? 100 for B, lot for C, and 50 for D. And then current on hand inventory, oh right, that is this strange little box to the left of everything else on the ending inventory line, available balance at the end of the period. So 125 is what it says for A. We have 875 of these B's sitting around right now, apparently. We have 55 C's, and we have 900 item D. Oh, okay, now this is all done. And you know, speaking of that, there's actually, with these records, a little bit of extra work. We really should label the weeks, because that's what these columns are, right? Each column in the record is one of the planning periods. It is asking us to plan for the next 9 weeks, so it's not a coincidence that there's 9 columns in these particular record frames, but they didn't come with labeling, so it might be important later who is who. I'm just going to do that. Now, step 1 was enter what we know, and we're done when we have entered everything that we know. Have we done that? Entered that. No. One last bit of information to enter. Let's see, anything mentioned on the master production schedule, well, only part A is mentioned, fine. The numbers on the master production schedule get entered into the gross requirements line of that item's record, the top line. Here is the record for A. I'm just copying the mention of A on the master production schedule over onto the top line of that record, because this is really what gets us started. This is our ultimate targets. This is what's going to be shipped out. It's required of us. All right, fine, done with step 1. We have entered everything that we know. What is step 2? Let's see, step 2 is calculate the planned order releases for all level 0 items, which is the same thing as fill out all the records on level 0. Level 0 is the top level. Well, it's just A. Yeah, okay, fill out the record for A. All right. I like to work along the inventory line, picturing what's going on. We have 125 of these right now, whatever they are. We're going to ship out 100 immediately. They're going to be consumed. That's just going to knock inventory down to 25. Then there's nothing going on for 2 weeks, and all of a sudden we're going to need to ship out 500. We'll have 25 in inventory going into that week, so we are 475 short. We'd better schedule to receive, plan to receive exactly that amount. I note that the lot size is lot for lot, so any number I want is exactly what I can have. That's great. That knocks inventory down to 0. And at this point, the thing I love about lot for lot is once you have wiped out inventory, the planned order receipts are super easy, and so is the available balance. Anything you want is exactly what you can have, just copy the numbers down. Okay, once you've wiped out inventory. Now wait a minute, this is when we want to receive these things. When should we order them? To finish this off, I check the lead time. It is 1 week. That means if I want 475 in week 4, I had better order it in week 3. 500, 100, and that 95 I want in week 9, I'd better order it in week 8 so that it is ready in time. And as we've been remarking, this is really the whole point of the entire record. This is how much we should order and when. All right, now, that was step 2. We filled out all the records on level 0. What's the next step? Enter the planned order releases of the parent items, in this case this is 1 item, into the gross requirements line of that item's children. Oh, in other words, pass those requests down. So I said, well, this is the only record that I filled out A, right? I know when I'm going to be making requests. B and C, those amounts need to be standing by when I make the request. So I take these numbers here, and since it's 1 to 1, I don't have to do any multiplying, multiply by the number of child items required to make the parent. I just need to take those numbers and pass them here. All right, so this 475, and I need to be careful that I'm in the right column, on the bottom line goes here, 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 and here, because this is a child of A. Okay, so, but the same thing here, since I'm going to request 475 A's, so to speak, in the 3rd week, 475 C's need to be standing by when I make that request. Same thing, same set of numbers, basically, for B and C. Say, okay, now, there, we did the next step. What's the step after that? Calculate the planned order releases for all records on the next level. Well, for us, that would be level 1, which is where we were just now, B and C. Great. Fill out the records for B and C. Oh, all right, let's see. B, we have lots. 875, 875, but going into the 3rd week, 475 will be claimed, so that will knock inventory down to 400, 400. We'll have 400 going into the 5th week. We're going to need 500. We're what, 500 minus 400, 100 short. Check the lot size. These come in batches of 100. Well, perfect. That's exactly what I wanted. That knocks inventory down to nothing. The next week, we then need another 100. Perfect. No inventory. We're going to have no inventory going into the 8th week when we need to have 95 ready. Okay, I'd better schedule then to receive 100. The lot size is 100, right? Think of it as they come in boxes of 100. That'll cover that. It does leave a little bit left over. All right, so for B, this is when we want to receive these 3 shipments of 100. Check the lead time. To finish the record, drop down to the bottom line and count 1, 2, 3. Order 100 here, 100 here, and then 100 here. I'm phasing all these forward by 3. All right, and then this one's done. That's when we want to order B. For C, we only have 55 in stock. So going into the 3rd week, we are what? 420 short. I check the lot size. Anything I want's what I can have. So I'm going to schedule to receive, plan to receive 420. Then that clears out inventory and lot for lot. Remember what I like about it? After you've cleared out inventory, just schedule exactly what was required, and you're never going to accumulate any inventory. All right, this is when they need to be received. Lead time is 2 weeks. Ooh, that 420 needs to be ordered immediately in the 1st week. Then 500, then 100. I'm just phasing everything forward by 2 weeks. That's when we place the orders. Done. Okay, it's done. Now what do I do? Well, now I repeat. For everybody on this level where I just completed the records, that's this one and this one, I then want to pass the bottom line of the parent down to the top line of the child's record, multiply by the number of children required to assemble one parent, if that's applicable. Well, actually, it's not applicable at all in the case of B. B doesn't have any children. That's great. I'm done here. I'm not quite done here because C is the parent of D. And that means that the bottom line of C now gets passed down to the top line of D's record. This is how many D's, so to speak, need to be ready to go and when. Once I have done that, I can fill out all the records on the next level, which is just level 2, which is just D. I'm almost done here. Okay, good thing I have 900 of these in stock because I'm going to consume or claim 420 immediately, so that leaves me 480 in stock, right? And then I have that 480 in stock going into the 3rd week when I need 500, so I'm what, 20 short? Nope, they come in boxes of 50, better get another box. So I will have 30 left over. I'll have 30 left over going to the 4th week when I need 100. Okay, I'm going to have to actually plan to receive 100 because that's the only way to cover it with these boxes of 50. So I'm left with 30 in stock. And I have 30 in stock going into the 6th week. I need 95. I'll need another 2 boxes, and that does mean the inventory will actually increase a little bit at the end of this. That's just some of the strange things that happen with lot size. Okay, anyway, this is when I want to receive them. Lead time 1 week, phase it forward. Done. Oh, phew. Okay, now what I keep highlighting in yellow is the actual action plan, but what are these questions that we need to answer on the exam? They're just spot checking your work. Using your MRP schedule, all that work we did, how much of Part C, okay, first off, which record, that one, will be in inventory, okay, available balance at the end of week 3. We're looking for a number, Part C, in inventory, week 3. That number is the number we retrieved, nothing, 0. Okay, using your MRP schedule for the next 9 weeks, Part B, which record, in inventory, which line, end of week 9, which column. Part B, in inventory, end of week 9, that's 5. Which of the following best describes some of the events taking place in week 4 at your facility? Okay, well, this is actually a very similar question, except it's kind of more in the style of triple true false. One thing that might help, maybe, since it's about week 4, as long as we don't mark up our work too much, I'm going to kind of try to use a highlighter pen to punch out week 4 so I can look back and forth specifically to week 4. Okay, an order for 475 A's will be completed, planned order releases. Is that number there in week 4? A's, 475 planned order releases, that is true. It is there. An order for 100 D's will be completed, planned order releases. Okay, that's the record, that's the number, that's the line. D, week 4, planned order releases 100, that is true. Okay, an order for 100 C's, that's the record and the number, will be placed, planned order releases. Careful, that's the line. Record, this is the week, planned order releases is the bottom one, that's the number? Yeah. So all of those tests true. So that would have made that one partial credit. Okay, and that is actually the 3 questions that are based on all of this work. Now, the last 2 questions here for the MRP, old exam questions, they go back to bill of material questions. I think both of them. Yes. Let's see, let's look at this one. Bartran Company assembles ink cartridges. Okay. Each finished ink cartridge has 3 child items, a plastic case, a label, and several ounces of ink. Lead time information, blah, 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 blah. You know what? I would draw this. Ink cartridge, or finished cartridge. Maybe that would have been a better label, but I just want to draw the finished good. Has 3 child items. What does that look like? Well, there would be 3 branches, right? And they are mentioning plastic case. Okay, so it would look like that. Label. So it would look like that. And several ounces of ink, which we're just going to treat as ink. Okay. And then, okay, so this gives me a place to organize. When I do this, we don't need to keep looking at the scratch work for that. The other information that was given. Okay, while the lead time on a new plastic case is 1 day, LT equals 1 day. The lead time on assembling a finished cartridge is 1 day. All right, I got that one. I got that one. Although the lead time is 5 days on procuring new labels. Ooh, don't let yourself run out of labels. 2 days for procuring more ink. Lead time is 2. All right. What is it I'm supposed to answer? Assuming that all the assumptions of an MRP bill of materials are true, how long would it take Bartran to create at least 1 finished ink cartridge if it started with nothing in stock? You're thinking, huh? This is actually a time-phased product structure diagram problem. Although, if you're good at picturing this, you could probably figure out just in your head, just with logic. But since technically this is a time-phase product structure diagram problem, I'm going to go ahead and draw a full-blown time-phase product structure diagram. By the time you see where the answer comes from, you'll probably go, oh God, do we really have to do all of that? Well, no, not if you could have pictured it accurately. But anyway, a time-phase product structure diagram is this, except drawn on its side from right to left, scaled by this information, right? So first off, I need some sort of grid. I'm not even going to worry about these being exactly accurate. I'm just drawing stripes here so that I can create a timeline in which each column is, what were they talking about? These were days, 1 day. So that I say, okay, ink cartridge is 1 day to finish off. I can represent that. It's this day right here. Now, they can't get started on that final assembly unless they have these 3 child items in place. So plastic case is also a lead time of 1 day. So I draw it below, or I should say actually to the left in the case of the time phase product structure diagram. And I draw it 1 day long. Right, that's the case. Versus the label. This is when it has to be done. I've got to drop back and grab 5 days. Because if you had nothing, you would first have had to have ordered it. This is all just the label right here. Waiting for the label or labels. And then the ink, this is when it needs to be ready. If you didn't have any 2 days before, you would have had to have ordered it. Ink. Here is where you'd be waiting on it. Yeah, this is basically a Gantt chart. So this is a Gantt chart. That means that this is time. So in order to answer the question, if we had nothing and had to order everything, how long would it take to finish one of these? Is you just drop back to the one part of this whole shape that is sticking out the farthest to the left, make it the start or 0, and just count. Oh, 6 days. Oh, that's A. If you had absolutely nothing in stock, then it would take 6 days. Let's see if we've got to draw a diagram for this last one. Suppose you made a sandwich from 2 slices of bread and 1 slice of American cheese. Suppose a friend of yours drew a product structure diagram to describe what you just did. Okay, maybe you two are studying for MGO 302. Which of the following is true about this diagram? You know what? I would draw it also. I always draw a picture, and I think I can squeeze this one in here. Okay, because you made a sandwich. That makes the sandwich the finished good. You made a sandwich from 2 slices of bread and 1 slice of American cheese. That means this sandwich, if drawn properly, is made from bread, 2 slices, and cheese. And you could write a slice of cheese. I'm just going to write cheese. And that's it. This must have been what your friend sketched. So we just want to test these questions. Or excuse me, I should say test these statements according to this diagram. The slice of American cheese is a level 0 item. This is the slice of American cheese. The level 0 item is the item up at the top. That's your sandwich. That has to be false. Now, level 0 items are finished good items. The cheese was not the finished good. The slice of American cheese is a child of your finished sandwich, which means the finished sandwich is its parent. The slice of American cheese, which is this thing, is a child of your sandwich. Yes, that is true. This diagram has a total of 3 levels. Okay, that's level 0, that's level 1. There's nothing more to this illustration. That is false. So that means that only the center tested true, and that means what that would have been partial credit in its day. Yes, that particular diagram, it's not tricky, only has 2 levels. That last statement was a very powerful distractor in its day on the exam. The only way that your sandwich could have had 3 levels is if bread was an ingredient in cheese, dot, dot, and then into the sandwich. Or cheese was an ingredient of making bread, dot, 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 which is obviously nonsense. That's not how one makes a cheese sandwich.